Next, focal distance of a point. The distance of your point on your parabola from its focus is called the focal distance of that particular point. Consider the parabola y square is equal to 4ax whose focus is s a comma 0 and directrix x plus a equal to 0. Right? This is x-axis, this is y-axis, O is the origin, this is the focus of that parabola s a comma 0, then this is the directrix x plus a equal to 0. Right? Let p x1 y1 be any point on the parabola. So considering a point p x1 y1 on the parabola, join sp and draw pm perpendicular to x plus a. Right? Draw pn perpendicular to x dash pn. Right? Now on equal to x coordinate of p. Right? On x distance of p, that is equal to x1, and oz that is equal to os, because the line y-axis is the bisector of the line segment SCZ. O is the midpoint, so OZ which is equal to OS which is equal to A. Focal distance of the point P which is equal to the distance from P to the focus, right? That is PS. We know that for a parabola SP which is equal to PM, SP by PM equal to 1, right? So PM which is equal to NEZ, right? PM which is equal to NEZ from that, right? But NEZ can be written as ON plus OEZ. ON is x1 and OEZ is equal to A, x1 plus A. Hence the focal distance of P is SP which is equal to PM which is equal to x1 plus A, right? So this is the parabola. So focal distance of the point, that is the SP is the focal distance. Parametric equation of a parabola. Next, let p x comma y be any point on the parabola y square is equal to 4ax. Aim to find a real t, that is called a parameter. We are going to find a t such that the coordinate of x comma y of p can be expressed in terms of t, because here you are having x, y, two variables, so we are make it in one variable t, right? Both x and y. For a greater than 0, x greater than or equal to 0, there x is a real t such that x is equal to at square. We can take x is equal to at square. Put x is equal to at square in y square is equal to 4ax. Therefore y square is equal to 4a into at square. So 4a square t square. Therefore y is equal to plus or minus root of 4a square t square. Therefore y is equal to plus or minus 2at. So the coordinate of p is in the form either a square comma 2at or a square minus 2at, right? So therefore the parametric equation of the parabola y square is equal to 4ax is equal to x is equal to at square and y is equal to 2at. Note that t is the only variable here. See, at square 2at, right? T is the variable, a is a constant, we know, 2 also constant, right? So this is the parametric equation, and any point on the parabola represented by the parametric equation, that is at square is x coordinate and 2at is the y coordinate. That is nothing but the parametric equation. Both are same only, right? Exterior and interior point of a parabola. A parabola divides the plane into two parts. The part which containing the focus is called interior of the parabola, right? Then other part is the exterior of the parabola. So now you are having a parabola, right? So this part included part which including the focus of the parabola, that is the interior part. The other side, that is the exterior part. Let p x1 y1 be any point on the plane, right? So draw pm perpendicular to x-axis which meets the parabola at q, right? That is x2 y2. Since q x2 y2 lies on the parabola y square is equal to 4ax, it satisfies the equation of the parabola y square is equal to 4ax. Put x is equal to x2 and y is equal to y2 in y square is equal to 4ax. You will get y2 square is equal to 4ax2. This implies y2 is equal to 2 root of ax2, right? Plus or minus both sides, we are taking the positive side, 2 root of ax2. Now pm is equal to y1, qm is equal to y2, that is equal to 2 into root of ax2, that is equal to 2 into root of ax1, right? Next, but in this case x2 is equal to x1, right? See OM distance, P is on the same line. See, check that P and Q are in the same vertical line, so their x distance is same, right? That is why x1 equal to x2. So pm square is equal to y1 square and qm square is equal to 4ax1. First case 1, suppose the px1 y1 lies outside the parabola, right? So pm, now as it is in the diagram, pm is greater than the length qm, right? Pm is the greater length than the length qm. So pm square greater than qm square if and only if y1 square is greater than 4ax1. That means y1 square minus 4ax1 value is greater than 0, positive value. If it is the positive value, if you are substituting the point x1 y1 on the parabola y square is equal to 4ax, if you get the positive value, then definitely that point lies outside the parabola. Case 2, suppose px1 y1 lies on the parabola. So if it is on the parabola, then p and q are coincide. So x1 equal to x2, y1 equal to y2, right? Both are same. So pm equal to qm, both distance are same. So pm square is equal to qm square, y1 square is equal to 4ax1. Suppose if you are substituting that point on the parabola, you will get 0, y1 square minus 4ax1, then the point lies on the parabola. Suppose the point px1 y1 lies inside the parabola, right? So this is the point inside. Now join. So q is there on the parabola, right? So qm distance is always greater than the distance pm, right? Here reverse. So pm is less than qm, pm square is less than qm square. So y1 square is less than 4ax1. So y1 square minus 4ax1, which is equal to a negative value, then definitely the point lies inside the parabola. So interior point. Thanks.